academia. We are still on our series on differentiation. Okay, in our previous video we have tried to explain, or we have tried to look at how to differentiate. Okay, in this particular edition, in this video, in this class, we're going to be looking at how to differentiate when our expression or our function y, in this case y, is a function of the product of two expressions. What I mean is, let's assume our y is equal to, let's say something like x squared, right, minus 4x multiplied by, let's say, x cubed minus 5x squared. All right, something like this, and we are asked to differentiate our y with respect to our x. Okay, that's what the product rule is all about. So we're going to be looking at how we can use our product rule. Okay, it's a simple format in differentiating this. All right, now our product rule simply states that our dy dx, in this case, now we're going to be naming these two expressions. This one, the first bracket, we'll be calling it our u. Okay, we'll be calling the second bracket our v. That means we'll be saying that this is our u and our v, so our y is equal to u v. Okay, u multiplied by v. Let me give a better u, okay, and the v. Okay, all right, so we are saying that when when our y is a function of the product of two expressions, okay, two given expression, how do we differentiate our y? So our format is simple. We are having, since this is our u and this is our v, what we do is that we hold our v constant, we differentiate our u. All right, so we're going to be having something like v du. Okay, so we're going to be holding, the first thing we'll do is that we're going to be splitting this, and then the next thing we're going to be differentiating our v. We're differentiating our u while holding our v constant, right? And then we add it to, we differentiate our u in this case. Then the next one, we differentiate our v while holding our u constant. So we'll be having stuff like this. Okay, so the first one we're going to do that, we differentiate our u, right? We differentiate this while this is constant. And the next thing we'll do is to differentiate this while this one is constant. All right, now let's apply that law on what we see here. Now our u is x squared minus 4x. This is our u. That the first one is always your u, right? So to differentiate our u, in this case the u dx, right, with respect to our x. Now we're differentiating our u. Okay, so we'll be having that word. Now we have seen how to differentiate in our previous videos. So we'll be having 2 multiplied by the coefficient. We'll be having 2x minus 1. We're left with 1, right? Then minus 4, because 1 multiplied by, and then we're left. This is it. So we have differentiated our u. Now the next one we'll be looking at is our v. Now our v is the next variable, the next expression here. We have our x cubed minus 5x squared. Now how do we differentiate our v in respect to our x? Okay, so we'll be having what? We'll be having 3x squared when we multiply and reduce 1 from the power, and then minus 10. Okay, minus 10x. We have differentiated our u and our v. Now so we're going to be applying our format. Okay, now we're going to be applying our formula. Since we have gotten our u, our du, our v, and our dv, we're going to apply our format now. So our format says, in differentiating y with respect to x, that is dy dx, right, we should say what? v du plus u dv. Okay, this is it. So the first thing we're going to do now, our v is this. All right, this is our v, x cubed minus 5x squared, right, multiplied by our du. Our du is this. All right, 2x minus 4. Then we'll be adding that with what? Our u. In this case, our u is up, x squared minus 4x multiplied by our dv. We have 3x squared minus 10x. And so let's expand our bracket, and then we'll add. All right, so in expanding our bracket, we use our first item to multiply the second bracket, use our second item to multiply the second bracket. Okay, so our x cube multiplied by 2x, x cube multiplied by 2x. Okay, so variable multiply variable, number multiply number. Since there's only a 2 here, 1 here, we have 2. All right, x cube then multiply by 1x by indices multiplication law. We add their powers, so we'll be having x raised to power 4. All right, for the next variable, x times minus 4, we'll be having minus 4x cube. All right, for our next item, minus 5x squared multiplied by 2x. So numbers multiply number, we have minus 10, and then our square multiplied by x. All right, indices power law, we'll be having x raised to power 3. Right, the next one we'll be having minus minus will be giving us plus. 5 times 4 will give us 20, and then we have our x squared. Right, now for our next, x squared multiplied by this, we're having 3x raised to power 4. Expanding, we're having 10x raised to power 3. For the next item, to multiply the next bracket, minus and plus becomes minus 12x to power 3. And then lastly, minus minus becomes plus 40x squared. All right, so we have finished expanding our bracket. So what we do is to rearrange. Okay, we bring all the numbers or all the expression with similar powers. If you can see, they are having different power. The x is having different power. Okay, so we bring all the similar powers together, then we can now work on them. Okay, so we'll be bringing in 2x raised to power 4, and then we have 3x plus 3x raised to power 4. Right, we have minus 4x raised to power 3, and then we have minus 10x raised to power 3, we have minus 10x raised to power 3, we have minus 12x to power 3. All right, so we are through with all this, and then lastly we have plus 20x squared plus 40x squared. So we have successfully collected like terms. Yes, we have collected our like terms. So working on that, 2x raised to power 4, they are like terms, right? So 2 plus 3, we have 5 5x raised to power 4. Now minus 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 minus. All right, so it's a negative. Minus 1 2 3 4, we'll be having minus 36x raised to power 3, and then lastly we'll be having plus 60x squared. All right, so we are through with our differentiation. So this is our dy dx. All right, to be giving us 5x raised to power 4 minus 36x raised to power 3 plus 60x squared. In this case, we have successfully differentiated this. All right, we have differentiated this like our x is a function of the product of two expressions. We have used our format to what? Differentiate this. You get your u and your v. So with this, we have successfully come to the end of differentiating using our product law. Don't forget to like our videos, subscribe to our channels if you haven't, share our video with as many as you can. We'll see you in our next class. Thank you.